Hi, everybody. I'm Pete Wall, and welcome to the September edition of the Kubernetes Monitoring Helm Chart Office Hours. We've got some cool stuff to talk about today. So we've actually been pretty busy since the last Office Hours last month. We've released two more feature releases, 3.4 and 3.5. So I'm going to talk a little bit about what's going on in both of those, as well as talk about some of the upcoming features, and we'll leave time for questions and answers. So 3.4. 3.4 was released on September 3rd, and it's got a number of notable changes. The most probably visible to a lot of you might be the removal of one of the post-install hooks. In 3.3, we added a hook that attempted to address any potential race conditions between deploying the Alloy instances and having the Alloy operator be up and running. And it did this by moving the Alloy instances into a post-install hook so that we knew the Alloy operator was going to be up and running with a running pod, and then we'd put the Alloy instances onto the cluster. It definitely solved that problem, but the issue was that by moving the Alloy instances into post-install, it kind of had some other ramifications. And so we undid that. The Alloy instances are back in the main set of manifest files. But what this does mean is that from 3.3 to 3.4, it might require a manual step to kind of reclaim those Alloy instances. We'll go into some more detail about that in the next slide. We added another destination called low-key standard out. This one allows you to take the low-key log data and print it to the Alloy logs output. And I'll explain a little bit more about why we went that way. And then we added support for TLS configurations in the remote config section, along with plenty of other fixes, and then updates to the upstream dependencies that we have in the Helm chart. Let me talk about the low-key standard out destination first. That one, oops, let me go back. All right, so that one looks like this. So here's the low-key standard out destination and how you define it. So in your destinations, here I'm using the destinations map, but you can use the destinations array. I'm defining a low-key destination as normal, but I'm also defining this new low-key standard out destination with a log processing rule to say I'm only going to keep data that comes from the production namespace. And so by enabling pod logs, since pod logs creates low-key type logs, it's automatically sent to both of these destinations at the same time. So if you were to inspect the Alloy logs own Kubernetes pod logs, you will see the logs that are coming off from this namespace. Well, why would you want to do that? Well, what happened was in version 1 of the Helm chart, let me go back to slideshow here. Oh, actually, I have a slide about this. Cool. In version 1 of the Helm chart, the cluster events feature had an option to log to standard out. So back in version 1, this was Alloy events. As Alloy events would get cluster events from the Kubernetes cluster, it could also log it to the standard out of Kubernetes or of the Alloy events pods. And we had a request to bring that over into the latest versions of the Helm chart. I thought about adding cluster events and log to standard out there, but what I opted to do instead was to create this low-key standard out destination type. So you can get the cluster events from the normal cluster events feature and then have it sent to the low-key standard out destination. And this would achieve the same thing, but it makes it much more flexible and generic so that other people can use it if they wanted to set something up. There's someone in the community forums who've been talking about kind of an interesting setup. They want to be able to capture logs and then save them and print them. And I'm thinking the low-key standard out might be a good use case for that sort of thing too. So there should be multiple uses for something like this. All right, so the upgrade from 3.3, when I talked about one of the things that we did in 3.4 was removing one of the post-install hooks. So like I said, in 3.3, we put the Alloy custom resources inside of a post-install Helm hook, with the goal is that it would stage those after the Alloy operator was set up. But the side effects that we saw after that's in the field for a little bit was that in certain install methods like Argo CD, it would see that these are Helm hooks, so I'm not going to actually render those manifests. And so they would actually just get skipped. That was a really bad part. in effect, it ended up meaning that those Alloy instances didn't feel like part of the main deployment, and so they kind of got sidelined sometimes. So in 3.4, we put them back into the main manifest set. The issue is that in 3.3, if you're upgrading to 3.4 or later, you need to tell Helm to re-adopt those Alloy CRs. So simply just run your Helm upgrade, but run Helm upgrade with the -- take ownership flag, and that will reset all of the required annotations onto those things. That's just a one-time flag. You only need to run it when you're upgrading from 3.3 to something later. All right, we talked about Loki standard at destination. So let's talk about k8s Monitoring Helm chart 3.5. Like I said, we were busy. We came up with 2 feature releases this month, and we had some really fun stuff and exciting stuff to bring into this too. So 3.5 was released about 2 weeks later on September 15th. And the notable changes there is that I have started the process of splitting up the pod logs feature. So for those of you who know, since 2.0, the pod logs feature has had a lot of options. It was able to read pod logs from the file system, which is its standard way. It was able to read pod logs from the Kubernetes API. And then I had stubbed in methods in there for doing things like a Loki receiver or using the OpenShift cluster log forwarder, those sorts of things that never got fully written out. And as that feature got more and more complicated, it became something that I wanted to do to kind of actually split it up and make it more targeted towards the individual tasks that it's supposed to do. So the first thing to happen now is that the pod logs via Kubernetes API is now its own separate feature. You can then create a pod logs feature. You can use the pod logs feature, the original one, using the file log or the volume-based log capturing in parallel with the pod logs for the Kubernetes API. Why would you want to do that? It allows for like a heterogeneous capturing of pod logs that really makes it much more flexible for more complicated clusters that you might actually have. Other notable changes, custom destinations. This one's super cool. I'm excited to share more about this in an upcoming slide here. Also, for the span metrics generation in the application observability feature, we are now by default removing internal spans. We found that these were just not helpful and just adding a lot of noise to the span metrics that are getting generated. So by default, we'll filter those things out. In 3.5, we allowed you to set scrape timeouts everywhere. This was something that was requested, and you could set them individually for some features. Now we're letting the scrape timeouts be set everywhere. And just like the last one, we've incorporated another set of good fixes. All right, so pod logs via Kubernetes API. Like I said, this splits out from the main pod logs feature. It replaces what in the main pod logs feature is the gather method equals Kubernetes API. That's still in there, so you don't need, if you're using that and it's working fine, you don't need to change anything right now. But we have marked that deprecated, and we won't touch it until 4.0. But if the rest of what I'm going to tell you about this pod logs feature, the split out Kubernetes API pod logs feature seems interesting, you might want to look into it more. Now that the 2 features are split, like I said, it allows for heterogeneous log gathering. So if you have Linux nodes on your cluster, that's kind of the most common, we can use the volume-based log gathering. There's a lot of advantages to using volume-based log gathering. It's my experience, it's more stable. It's persistent to restarts both of the Alloy pods, but also of the individual pods themselves, because those log files are persisted onto the node's file system. But if that's not feasible because you're running nodes that are managed nodes like on EKS Fargate or GKE Autopilot, then you can use the API log gathering. If you're running Windows nodes and we can't get to the file system on that, we can use API-based log gathering. Or for any other system, if you have a cluster where the host path volume mount is just disallowed and you can't get to that, you can use the API-based log gathering for those. Windows, I would love for that to have volume-based log gathering. That is something I'm thinking about, and I'm trying to figure out the best way to do that in the future. But for now, the API-based log gathering is probably the best option. So how did this look in practice? So if this is kind of what we considered, like we have a cluster here, and pretend this maybe is an EKS cluster with 2 traditional Linux nodes and 2 EKS Fargate nodes, where they're nodes, but they are fully managed nodes by the EC2 or the EKS system, right? In this example, the Alloy logs daemon set would be deployed to the more traditional nodes, and it's able to read the log files by going to the host path volume mount and reading var log pods. But unfortunately, we would skip any pods that are running on those ephemeral nodes because var log pods doesn't exist. You can't get to that log file path. So these arrows kind of show the traditional volume-based log gathering. And so if you had these ephemeral nodes, in the past, the guidance was switch to API-based log gathering. So all of the Alloy instances would talk to the API server. You would stream the pod log data from all of the pods straight from the API server. And this works. It's nice. It's flexible. But the downside here is that it adds a lot of network traffic internally to the cluster, and you're adding a lot of load onto the API server. So by having 2 features, one pod logs feature for the volume-based monitoring or volume-based log gathering, and a now pod logs via Kubernetes API feature for API server-based log gathering, we can do both. And so you enable both, and you tell the API server-based log gathering, I'm only interested with pods that exist on these nodes or something like that. And so then you can get all of your pod logs in the most efficient way possible. All right, 3.5 also brought in custom destinations. So since forever, we've always had the ability to supply extra config. This is a little bit of background. So in the Alloy definitions, you can supply extra config. And this allowed for you to add arbitrary Alloy configuration for anything that you wanted to. This was really great for adding new data sources that we didn't have features for. So statsd exporters, or like the MongoDB Atlas connection. We don't have built-in features for some of these things, and so the guidance was, hey, write it up in extra config, and then you can wire it into the existing destinations for sending metrics, logs, traces, profiles. This was great for that. It was fine for defining whole pipelines. If you wanted to add just basically arbitrary config to gather data, process data, and then deliver it somewhere, you could do that through all of extra config. But it was not something that you could use if you wanted to gather, say, like the pod log data or cluster metrics from our built-in features, and then send that to a custom destination. Because of the way that the Helm chart works, we kind of do some complicating routing of the data from data source to data destination. And you couldn't use extra config to create new destinations until we added the custom destinations. So custom destinations is a new destination type called custom, and it has a few required fields. First is config. I'll show a demo of this, or show some examples of this in just a second. But the required fields are the config, which is just like extra config. It's the raw Alloy config components that you want to use for that. You define the ecosystem, which says what's the native type this config is supposed to accept. I'll explain a little bit of that when we look at the details. And then you need to enable at least one of the data types. So is this config meant for metrics or for logs or traces or profiles? Or perhaps it's meant for multiple, like on some of the OpenTelemetry type components. And then for all of the data types that you enable, you need to specify an Alloy input target. So where, like, how does Alloy know where to send this data? What's the component that you need to send? So let's here, yeah, all right, great. Here's an example of us making like a Kafka custom destination type. So in the destinations list, I have type is custom. I can name it Kafka. And then in the config block, this is the Alloy components that I want to add for this destination. And so we're doing 2, actually. We have the hotelcall.exporter.kafka for the actual Kafka exporter, but we're going to run it through a batch processor first. So the first input should be the batch processor, which then batches things and then sends the log data out to the Kafka exporter, which then defines how we're going to send it out. And so the second required field is the ecosystem. This is an OTLP type because it's using the hotelcol.exporter. If it was something like, Loki dot something, then it would probably be the Loki type. Logs are enabled. All of the others are missing from this definition, so they're disabled by default. And then the target for logs is this. And so this hotelcol.processor.batch.kafka.input says this is the component where I want you to send log data to deliver to this destination. So custom destinations is a great way to add more destinations if you have something where you want to send your data to that's not in the built-in official destination types. We have Loki, Prometheus, Pyroscope, OpenTelemetry, and now Loki Standard out. But if you wanted something different, like you want to export data to AWS S3 and we don't have that built in, it's a great way to add that sort of functionality in there. And honestly, it opens up the idea for building pretty complex pipelines because it's in the destinations, but there's no reason why you couldn't accept data and then you can use all of Alloy to do anything that you want with that. So processing it, redelivering it to a different, Alloy instances or something like that. There's a lot of potential here. Let me switch back over to my examples here. So this is the same custom definition for Kafka that we just saw a second ago. Here's another simple one, just a debug destination. So it's using the hotelcol exporter.debug, which prints into your standard out stream for the Alloy in this case. It prints, here's how many traces arrived, here's how many logs arrived, or metrics or things like that. And so in this one, ecosystem is OTLP again, but metrics, logs, traces are all enabled. And so this destination is available for anything that generates metrics, logs, or traces to be sent to this destination. So in this example, I'm using annotation auto discovery to gather some metrics, and I'm forcing it to say the destination for this is this new debug destination. And so as those metrics are scraped, it's going to go into here and it's going to run into this component, which will then print the metrics that it's gathering into the Alloy metrics debug stream. It's really cool once you try it out. I'd love to hear what sort of custom destinations that you are building. So if you try this out and you build a custom destination, let me know. So that's the recap of 3.4 and 3.5. In the upcoming features, we are actively working on both of these top two. The front-end observability feature we'll be using the very specific Pharaoh destination. We're working through some final changes on that, but we're excited to get that in your hands. The database observability feature. So this one is using the database observability components in Alloy to do some inspection on not just the databases that you're running, it's MySQL or Postgres, but also some query analysis into that. So there's some really interesting stuff that's going to be coming there. And having a database observability feature will make it a lot easier to get that up and running. I'm still looking into the ability of running without cluster roles and using only roles and role bindings. After doing some testing with this, there's a few caveats that I want to put into that. Some cluster roles are required for the cluster metrics feature because some non-namespaced things like nodes can only be given permission for access with cluster roles. And so things like getting the kubelet metrics aren't really possible because you need to first get all of the nodes. And so some of the features will not be compatible if you have no cluster roles. But I'd love to, when we get further along and we have this feature in there, the actual change for Alloy is still in review. But I'd love to, I'll have proper documentation on how you can minimize the amount of cluster roles that you need to make. Finally, cloud provider label enrichment. If we detect that you're running on EC2 nodes, can we use that information to add tags and labels from your EC2 instances into the metrics that you're generating or the logs that you're gathering? That's some interesting stuff. And then finally, Agents.md. So I've been working more and more with some of the AI tooling, and I'd love to make a really useful and effective agents.markdown file that can live in the repository. So if you have questions about how the repository or how the Helm chart is built, or hopefully even just questions about how to enable features, there will be some affordances into the repository itself to make it easy for those AI agents to actually get the accurate information for you. So I've been working with that, and I'll be excited to put that in there, but I don't want to put it in there until I know that it's going to be useful for actually answering real questions. All right. I know that was a ton of information. Thank you for bearing with me on all that. Now we've got time for questions and answers. And I don't think there's going to be any. So thank you so much for watching. I appreciate everyone who uses the Helm chart and gives feedback. It means a lot. Like I say, every month, this is a heavily community-driven project. And so your feedback means a lot to me. So please, if you have questions, if you have comments, you can join us on the Grafana public Slack, grafana.slack.com. I hang out in the hashtag Kubernetes channel there. If you have issues or feature requests or anything, you can find us on the GitHub repository Grafana/k8s-monitoring-helm. And again, thank you so much for watching, and I hope you have a great month. We'll see you in October.